Okay. Alright, so we gotta think, what do we want to be our U, what do we want to be our dV?
So
So have U be X squared. Have U be in, because D wouldn't be that bad though.
So if this is your dV, what is your antiderivative of that?
Antiderivative LX.
That's the derivative.
Antiderivative LX. Do we know that?
Is that the absolute value thing?
I think so.
ln absolute
Is it
value
1
of
over
x.
ln absolute value?
Don't recall off the top of my head.
That's the derivative.
That's a
We need to
neat
do
one.
that, right?
I'm gonna go the other way. I'm gonna say this is my.
And that's normal
U.
derivatives.
I'm gonna say U is ln x. So
Actually,
du
I don't-
needs to be 1 over x.
dx.
So then, if this is my U, then
What?
dV is gonna be x squared dx.
And then your v is gonna be 1/3 x cubed. Nice. Nice.
Yeah, I guess that doesn't look that bad.
Because then thinking about it, the V du part,
Is that because you have your overs?
that's because they're gonna kind of cancel each other out and it'll be a fairly simple function. Everybody see that? Right? So again,
U dV.
the antiderivative of u dv, uv minus the integral of v du. So I rewrote the stuff over there so this matches the u dv part. So ln x times 1/3 x cubed minus the antiderivative 1/3 x cubed times 1 over x dx. So far so good? I'm going to simplify this into a little nicer looking fraction. I'm going to make it x cubed ln x all over 3. I'm going to multiply those things together. I'd get 1/3 x squared dx.
Sorry.
That'd be X to the
Wait,
negative first,
what happened to the
essentially,
1
right?
over x?
I multiplied it by the x cubed.
Oh.
See it?
That was sneaky.
X to the negative first, yeah.
Please. Quick.
Um, 1/9 x cubed. I believe that would do the trick.
Yeah.
So what happens if you add like a B and an A value? You just do that and
Yeah.
put it in minus
Yes.
the,
Yes.
So
but you do the whole thing. Or you just do the 1/3,
You would just
that part.
right here and then
Okay.
have your values. Yeah.
so Would you prefer it to be like that, or would you prefer it to end up, because it's fairly easy to make that into a common denominator and then just write all of it over.
I wouldn't.
That's extra step.
I'd leave it.
Okay.
And if you wanna keep this, if you wanna move along, if you like fractions, out in front, if you wanna write 1/3 x cubed ln x minus 1/9 x cubed, go for it.
Okay.
They can simplify it less.
I'm so tired.
There are a couple of them. And you'll, I think 28 does it. You might have to do integration by parts a couple times, because after you do integration by parts once, what you're left with right here, while it's a little bit simpler than maybe what you started with, it will need an additional integration by parts to help you do that one. And then you'll eventually be able to get it done.
So,
Do twice.
Mm-hmm. Yep.
Say we've definitely done.
what?
I know I did 28. 28 required it, yes, 3 times.
So,
It only took that much space.
would there be, not that you'd give us any like this because you're not that mean, but could there theoretically be like one that you have to do 20 times or 30
Yeah.
times? And is there ever going to be a rule that makes it so that you don't have to do it over and over to make it simpler, or?
I
Is
don't
this
know.
the
I,
type of
I
thing?
honestly don't know the answer to that
Okay.
question. I would think something that complicated, you would be best off setting up some sort of program to run that over and over again
So
for
that
you.
is fairly easy to do.
So,
Wait, so how do you know, cause it says like, for the 11 through 38, it says like not all require integration by parts or whatever.